to study the sign of the first derivative. So I don't have the signs, but I have the critical numbers. The critical numbers are negative 3 and 3. So those I have. I have to have them. And then I realize that the function where the first critical number is, the function looks like this. What should be the signs left and right of the first derivative? Or what type of point should negative 3 comma 54 be? I have my preps here. So one more time. So let's suppose I decide not to study the sign of the first derivative. Not a good idea, but let's suppose. This is also a way of checking our work. So we have a critical number, negative 3. The function value is 54. And I know that this is a critical number, and I also know that in this interval, where the critical number is, the function looks like this. My question is, what type of point can negative 3 comma 54 be? Anyone, please? Lauren, what do you think?
I'm actually just not sure. I'm sorry.
Okay, look at the function. What type of point can it be? Quinn, what do you think?
A maximum.
Of course. There is no other way. If there is a critical number in this interval and the function looks like this, there is only one option. Of course, thank you. It's a relative max. Let's look at the other one. Okay, so I have 3 comma negative 54, and the function, and it's a critical number, not just any point. It has to be a critical number. And the function looks like this. What type of point could that be? 3 comma negative 54.
Minimum.
Of course, there is no other way. If it opens up, it must have a minimum. So now I can check the signs of the first derivative. If the function looks like this and it has a maximum, this must be positive and this must be negative. There is no other way. And if it has a minimum, definitely this has to be a negative and this has to be a positive. So this is another way of checking my work. Again, how do I check? By looking at the second derivative. And when the second derivative shows me that when it's negative and it shows that the function has to look like this, and there is a critical number, like negative 3 in that interval, the signs have to be plus and minus. If there is a critical number and the second derivative shows me or tells me that the function opens up, and there is a critical number here, this critical number, this critical point, if you want, has to be a relative minimum. There is no other way. And the signs have to be negative, positive. So I know the table is correct. I checked with the first derivative, I checked with the second derivative, and they all work. That's what was the comment I wanted to make on this problem. Okay, so enough of that table. So let's look at another problem. Let's choose. And this was, I think, was problem 13, if I remember correctly. Okay, so we worked on number 13. So we want to, now at this point, we are allowed, I shouldn't say strike that. Now at this point, we have all the information we need to graph a function. Moving forward, we can. So we can even go back to the previous table and graph the function, or just simply move on to another function and show the table, the whole thing, plus the graph. Let's not choose rational functions, only because the next section deals with them. That's the entire section. 3.3 will deal with rational functions and nothing else.
14.
14. Okay, let's take a look. We want to choose 14. And 14 on page 291. 14, we have g of x equals x to the third minus 48x and minus 1. Okay. So at this point, we can complete the table, and also based on the table, we can graph the function. So right now we are asked to do the whole thing. Okay. So first of all, I need to determine the domain. As long as you fill the table correctly, you do not have to write everything on the side. You can put it in the table. So for example, when it comes to the domain, you don't have to write the domain is ta 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 ta. You can just simply put it in the table. Can anyone tell us what is the domain of a polynomial function?
All real numbers.
Indeed, always. Any polynomial function is a friendly function. Perfect. I have to find the x and y intercepts. X and y intercepts always. We always look for the x and y intercepts. Can anyone tell us when x is 0, how much is y? When x is 0, how much is y? Please.
-1.
Perfect. Thank you very much. So 0, -1. Perfect. Now when y is 0, we have x cubed minus 48x minus 1 equals 0. We will use the feature in the calculator. Apps 9 polynomial root finder. Careful, you have to move to 3 because the degree is 3. The first coefficient is 1. The next in line does not exist, so it's 0. The next in line is -48. And the next in line is -1. So now we have 3 real solutions. So I'm going to write x1 as 6.9, x2 as -6.9, and x3 as -0.02. Good. I have to put them in the table. 6.9, -6.9, and -0.02. 0, 0, 0. Final step, I need to find the limits. The limits. Limit as x approaches -infinity from x cubed minus 48x minus 1, and limit as x approaches infinity from x cubed minus 48x minus 1. Good. So let's think. Which of these 3 terms, because we are talking about infinity and negative infinity, if x approaches 2, everything is important. If x approaches -3, everything is important. But when it comes to infinities, I'm going to ask myself or ask you, which of these three terms is the most powerful?
Dx cubed.
Of course. So in other words, this piece is so small that it doesn't matter. So please plug in negative infinity and then plug in infinity and tell me what I should write. When we plug in negative infinity here, what do we get? Letitia, what do you think? When we plug in negative infinity here, what do you think we get?
Honestly, I'm not sure, so I can't really answer it. I'm still a little confused.
Negative infinity to the third power. What do you think it means? Anybody?
Would it be 0?
Negative infinity.
Sure. It's so huge, so big, that it can not approach anything else but negative infinity. What about this one?
Positive.
Infinity?
Of course, absolutely. So carefully, we put them where they belong. I am done with the function. There is nothing else I can find about the function from the function itself. This is it. X and Y intercepts and limits. That's it. Now I move on to the first derivative. Okay. Good. That's my page 2. So I'm going to copy the function here, g of x equals x to the third minus 48x minus 1. So I have to find g prime of x. Anyone would like to give us g prime of x?
3x squared minus 48.
Very good. Of course, I will factor out a 3 to see what's going on here. And I see x squared minus 16. Ah, I like it. Okay, so I have 3, and I will continue factoring. Can anyone give us the factor form of x squared minus 16?
X minus 4 plus times x plus 4.
Excellent, thank you very much. Good. So now when I set g prime of x equal to 0, or the other source g prime of x equals undefined, will I get anything from here? Can this be ever undefined?
No.
No. Good. So what do I get from g prime of x equals 0? I already have the factor form. I can already identify those.
Negative 4 and positive 4.
Good. So I go back to my table. It's going to get very crowded in here. So a negative 4 and positive 4. Immediately I have to identify the y value for the critical numbers. And you know exactly what I'm going to do. In y equals, I will put this function x to the third minus 48x and then minus 1, and I will plug in positive 4 and negative 4. So negative 127 and no, that's positive. The first one is positive, and negative 129. Okay. The next step is to find the signs. Study the signs of the first derivative. Here, here, and here. So this is the function. 3 doesn't count. It's a positive number. I don't care for it. It's not going to change the sign. But when I plug in negative 10 to the left of negative 4, any number, negative 10, negative, negative. When I multiply two negatives, the outcome is positive. When I plug in 0, because 0 is between negative 4 and 4, I get negative 48. And when I plug in 10, I get positive and positive, so it's positive. Good. Now I need to identify these points. Which points? This point and this point. Can anyone tell us what they are? Negative 4, comma 127 and positive 4, comma negative 129. What are they? What is the first one?
The first one is a relative maximum.
Indeed. Excellent. Because the signs, it tells us that this is positive and this is negative. So from negative infinity to 0 to 127, the numbers and the symbols match this. Positive, which means increasing. From negative infinity increases to 0, yes. From 0 to 127, yes. Good. So this is definitely a relative max. Let's see what happens next. Decreases, yes. From 127 to 0, yes. To negative 1, yes. To negative 129, yes. So this matches as well. From 127 down to 0, down to negative 1, down to negative 129. Now I reach this point, 4, comma negative 129. What type of point is this? As long as I see increasing, yes. From 0 to infinity, yes. Everything matches. So this row and this row, they work in sync. When it's increasing, the numbers are increasing. When it's decreasing, the numbers are decreasing. Everything follows, they follow together. Okay, so what type of point is 4, comma negative 129?
A relative minimum.
Indeed, because it's decreasing and then increasing. Excellent. Okay, what have we accomplished so far? We exhausted the information coming from the function. We completely exhausted the information coming from the first derivative. We are done with both of them. Now we have to study the second derivative because the second derivative tells us concavity and inflection points. So we go back. Here's the second derivative. G double prime of x. This is the first derivative. Can anyone give us the second derivative?
(6x).
Perfect. Okay. Again, G double prime of x equals 0, or G double prime of x is undefined. No, it's a polynomial function. So when is this 0? When x equals? When is 6x equal to 0? When x is?
Less than 0.
0.
0. Yes. Only 6 times 0 is 0. 6 times a negative number is not 0. Good. So here it is. Luckily for me, I don't have to add more to this crowded table. And I have to study the sign left and right. So can anyone plug in a number to the left of 0 in 6x and tell me the sign? Any number to the left of 0 to be plugged in here, and just tell me the sign. No calculations are required.
Negative.
Of course, which means it does not hold water. concave downward. Can anyone plug in 6x any number to the right of 0 and tell me the sign of the second derivative?
Positive.
Indeed. Which means the function holds water. Stop for a moment. I see a critical number when the function opens downward. Is this okay for this to be a relative max?
Yes.
Perfect. I see the function opens upward according to the second derivative. I see in here there is a critical number. Is it okay for this critical number to be a relative min?
Yes.
Yes. All rows in this table work perfectly together. I'm ready to graph. I don't care for anything else. I don't need anything else. I don't need to look anywhere else. This is all I need. I don't care for anything else. This is it. So, good. Plot the points first. Negative 6.90. I'm going to use a different scale here for the y-axis because I can't get to 127 and negative 129. So 1, 2, 3, 4, 5, 6, 7. So here is the first point. And negative 4. 1, 2, 3, 4. Here's negative 4. Positive 127. 50, 100, 150, somewhere here. The next one, negative 0.002, comma 0. The next one, 0, negative 1. The next one, 4, comma negative 129. 50, 100, 150, somewhere here. 5, 6, 7, so here. Perfect. Now I'm ready. I'm ready to connect these. Let's see if I can use a different color. Okay. From negative infinity, the function is increasing to the first x-intercept, opening downward. Again, from negative infinity, the function is increasing, opening downward to the first x-intercept. Continue. Increases to this relative maximum, opening down. Fine. Decreases, still opening down, to the next x-intercept. Fine. At this point, continues to decrease to the, I forgot to mention here, IP. Continues to decrease to the y-intercept, which is also the IP, inflection point. At this point, the function changes concavity, continues to decrease, opening upward to the relative minimum. Still opening upward, increases to the next x-intercept. Continues to increase to positive infinity, opening up. One more time. I plotted the points. This point, this point, this point, the y-intercept, the other critical number, and the other x-intercept. All points were plotted. Now I follow the table. from negative infinity. It crosses the x-axis the first time, opening downward, continues to increase to the relative max. Then continues to decrease this time from the relative max, decreases to the next point of intersection. Continues to decrease, still opening down to the y-intercept, which is also the inflection point. At this point, it changes concavity, opening upward, reaching the relative minimum, opening upward, decreasing to this point, and then it's increasing. After it reaches the relative minimum, it's increasing now, opening upward to the next point of intersection, continues to increase to infinity, opening up forever. And this is f of x, I'm sorry, g of x, x to the third minus 48x minus 1. Again, I cannot stress enough, this is our first application of differentiation. Copying a graph from the graphing calculator will not bring any credit. Now, after I'm done, yes, I can check with the graphing calculator, why not? I know exactly what viewing window I need because I did all my calculations. So the viewing window, negative 7 to 7 or negative 10, 10 is fine, but the y is not. So I'm going to say negative 150 to positive 150, and with a scale of 25. Here it is. Exactly as we expected. And we know it does not cross at the origin. We know it does not cross at positive 7, because we already performed all the calculations. If you want to determine this just to check, you go to second-hand calc, and you want a 0 or the x-intercept. It will ask you for a bound, and I'm going to say between between 6 and 10. So I'm going to say the left bound is 6 and the right bound is 10. No, I don't want to guess. I know what it is. It's 6.9. Here it is. It's not 7 because we performed all calculations. It's 6.9385 and y is 0. Can I determine the max or the min? Of course. To double check, I can with, oh, sorry, no, I meant that. And I want to determine a maximum, 4. And I know the maximum is between negative 9 and negative 5. Because I performed all my calculations on negative 5. And I know what it's going to say. It's going to say negative 6.9, 127. No, I don't want to guess. I didn't give the correct range. Again, maximum 4. So again, it's between negative, what did I enter? Negative 8 and negative 4. Oh no, it was at negative 4, sorry. And negative 3. Okay, so I know what it's going to say. It's going to say negative 6.9 whatever, comma 127. It must, because we performed all the calculations. I'm sorry, I'm still looking at negative 6.9, sorry. So at negative 4, this is the error of the calculator, the 0.000001, and y equals 127. We don't need a calculator. We can do our work perfectly. Negative 4, comma 127. That was the relative max. Okay, any questions on the procedure? Any questions on the steps? Anything you'd like to ask? Anything? Anything?